Okay, welcome to section 5.3, where we'll be discussing the properties of trig functions. So we will go through our unit circle, how to find different angles, also how to find then the xy coordinates, and using some identities. So let's look at what we have today. We're going to determine domain and range of trig functions. We're going to determine the period of trig functions, the signs of the trig functions in a given quadrant, the values of trig functions using fundamental identities, the exact values of trig functions of an angle given one of the functions and the quadrant of the angle, and even and odd properties. So let's jump right in. Oh, here we go. Determine the domain and range of trig functions. So if we recall what domain and range is, domain is the x values of our function, and the range is the y values. So all of the x values that are covered in a function ranges all of the y values that are covered in the function. So let's first look again. We recall from the last lesson, sine theta, or sine, is our y value. Cosine is our x value. Tangent is sine over cosine, or in other words, y over x. Of course, x can't be 0. We can't have 0 in the denominator. Cosecant is 1 over y, or in other words, 1 over sine. Okay, we'll discuss that a little more. Secant is 1 over cosine, or in other words, 1 over x. It's the reciprocal. And then cotangent is a reciprocal of tangent, which flips this and becomes x over y. So when we're looking at domain and range, let's look at a quick graph. Okay, so if we jump onto here, and let's say I do sine x. So there is our domain of our function, or this is our function. This is the function sine x, okay? It's what we call a periodic function, and it's a wave where we get sine waves and cosine waves having to do with sound and we can use it for anything and everything because a lot of the world around us repeats when it comes to like tides and um, us revolving around the sun, all of that. So let's jump here. I want to cover something here real quick, and we're going to go over a quick unit circle again. So see if we can see that in the middle. Here's our y-axis. Here's our x-axis. Okay, let me put that up there. So if we recall, our three angles that we deal with in each quadrant then is our 30, 45, and 60. Then of course we have our 0 degrees and our 90 degrees. This is 30, this is 45, and this is 60. And then our radius of our unit circle is always 1, if we recall. So then if I look at each of these triangles, my hypotenuse is 1. Here's my 90-degree angle. We have our y value and we have our x value. So let's go through and recall. I'm going to knock these out. I'm going to do a quick unit circle, hopefully recall how we did this in the last video. These are just real rough sketch. But if we recall, a whole 180 degrees is 1 pi. So then we know 30 is pi divided by 6, or pi over 6. 45, there's 4 45s that go into 180. That's 180. Let me put this on the inside because we'll deal with our x and y coordinates here in just a moment. So these are just the angles, right? This is the angle coming off of this triangle. So if we recall, that's our triangle. This is my x value, this is my y value, and this is my hypotenuse, or in other words, my radius. So 45, we have 4 of those that go into 180. 60, we have 3 of those, so pi over 3. And that's in our radians, right? These are radians. These are degrees. And then, of course, our pi 90 degrees is pi over 2. Okay. Now, how I like to think of these that are around the pi or the 180. So our denominators that we have are 6, 4, 3, and 2. So we know then our 60 degrees away is going to have a denominator of 3. We know our 45 degrees away from the x-axis, denominator of 4, and the one closest to the x-axis is denominator of 6. We can do that on around here. This one's denominator of 6, denominator of 4, and denominator of 3. And then this started at 90, so it's denominator of 2. And then again, the one closest is going to be denominator of 6. One here in the middle is denominator of 4, and then this one will be denominator of 3. All right. Now, if I think of pi, 1 pi, well, that would be 3 pi over 3, correct? So I think of that 3 pi over 3, 1 less would be 2 pi over 3. 4 pi over 4, because that is 1 pi, right? 4 over 4 is 1. Then 1 less would be 3 pi over 4. 6 would be 6 pi over 6. And so this would be 5 pi over 6 because it's 1 less. Of course, we're going around in a counterclockwise direction from our 0 degrees here at the positive x-axis. Well, this is 90. This is 30 more than that, so that's 120. This is 45 away from the 180, which is 135, and 30 away, which is 150. 30 more would be 210 because that's our 180. 45 more would be 225. And then 60 more would be 240. 90 more would be 270. And then we think of less than. This is 360 degrees, so 30 degrees less is 330. 45 degrees less than 360 is 315. 60 degrees less is 300. All right. And then our radians, well, this is 6 pi over 6, so 1 more than that would be 7 pi over 6. 4 pi over 4, 1 more would be 5 pi over 4. 3 pi over 3, 1 more, 4 pi over 3. This is 2 pi over 2, so this is 1 more than that, 3 pi over 2. And then I look here. If we go all the way around this circle, this is 2 pi, right? So I have 0 degrees here really on this side, and I have 2 pi on this side, or in other words, 360 degrees, okay? So it's 2 pi, 1 pi, 2 pi. So if I have 2 pi, well, with a 6 as denominator, that would be 12 over 6, which is 2. So that's 2 pi over 6. 12 pi over 6, which is 2 pi. So then 1 less than that is 11 pi. I have 8 pi over 4. So 1 less than that is 7 pi over 4. And then I have 6 pi over 3, which is 2 pi. 1 less than that would be 5 pi over 3. So that gives us our quick angles of each of these, our angles in radians and in degrees going around the entire unit circle. And then we have our XY coordinate points. Okay, trying to spend as quick a time as I can on this so we have this down. Our XY coordinate point. So in other words, how far X do I go? How far Y do I go? Well, our radius is 1, so I'm going just 1 X, 0 Y, because I'm not going up at all right here. Here, if we recall, my X is root 3 over 2, and my Y is 1/2. One thing I want to point out on every one of these is cosine is my X, sine is my Y. So recall that as we go through. So cosine of 30 degrees, or cosine of pi over 6, is root 3 over 2. Sine of pi over 6 is 1/2. And then our 45 is root 2 over 2 is my X, and root 2 over 2 is my Y, or my cosine and sine. Now, really, those are the only two that we really need to kind of memorize. Reason being is because then my 60, or my pi over 3, is just flip-flopped. So then this one just becomes 1/2 and root 3 over 2. So my cosine of pi over 3 is 1/2. My sine of pi over 3 is root 3 over 2. This point here, well, I didn't move left or right, so my X is 0. And I went up 1 because my radius is 1, so my point is 0, 1. And then all of the rest of these just reflect off of these. So I can see this one has 3 as the denominator, so it's just going to reflect 1/2 root 3 over 2. However, my X is negative, my Y is positive, if I were to create my triangle. So my X is negative, my Y is positive. Here, negative root 2 over 2 and positive root 2 over 2 would be this point. this point, because I'm 30 away, or my 6 is a denominator, is going to be negative root 3 over 2 positive 1/2. Just reflecting from that one. And then here, I'm going negative 1 of my x and 0 as my y. So that's just this point right here on pi. And then I reflect again going with my 6's. However, I'm going negative x and negative y. So I'm with my 6 denominator, negative root 3 over 2, negative 1/2. 4 is the denominator, negative root 2 over 2, negative root 2 over 2. And then here reflect negative 1/2 and negative root 3 over 2. Reflect these from our original. This point's going to be, now I have positive x, negative y. So positive root 3 over 2, negative 1/2. And that is my, of course, my cosine of 11 pi over 6 is root 3 over 2. My sine of 11 pi over 6 is negative 1/2. Okay, this point then, positive root 2 over 2. Let me fix that a little bit. Positive root 2 over 2 and negative root 2 over 2. So I'm going negative as my y. Here, positive 1/2, negative root 3 over 2. So that is our unit circle all wrapped up. Try to go over that fairly quickly again for you, so we have an idea. Let's get some of that out of the way. So hopefully we see that. All right. Reason I went through all of that is, there we go. Let me minimize this. Is we're looking at domain. So if we look at this, then my domain of my sine is my x values. Well, my sine is my y. I start out at 0. I go to 1/2, root 2 over 2, root 3 over 2, and I go up to 1. And then I go root 3 over 2, root 2 over 2, 1/2, and back down to 0. So I start at 0, I go up to 1 for my sine because it's my y, and then I go back down to 0. And then what happens? I go negative 1/2, negative root 2 over 2, negative root 3 over 2. Oh, and then this one is, of course, my x is 0, and my y is negative 1. So I'm now go from 0 to negative 1, and then I go back down to 0. So I go 0 to 1 to 0 to negative 1 to 0 to 1 to 0 to negative 1 to 0. And as this becomes larger and larger as I'm going around in a positive, then it just keeps repeating, right? So what is that repeating? That's what we call a period. So here my sine, my y value starts out at 0, goes up to 1, comes back down to 0, goes to negative 1, comes back up to 1 again, so forth and so on. So it just repeats over and over. Same if I'm doing negative angles, right? Okay, so I just want to point that out. So my x values, or my domain of my sine function, goes on forever left and forever right. So that's all real numbers. My range will go from negative 1 to positive 1. That's the lowest I go with no transformations, and we'll deal with transformations later. But just a sine of x with no transformations, I go from negative 1 to positive 1. That is my range. Okay. So if we look back here, then this goes. The domain of a sine function is the set of all real numbers. The domain of a cosine function. So let's do a quick glance of that. So cosine, if I just plug in cosine x, well, it starts at 1, goes to negative 1, goes to 1, goes to negative 1, but it goes forever as well. Because if I think of cosine, which is my x value, I'm starting out at 1, going up here to 0, going down to negative 1, going here to 0, and then going back to 1. So 1 to 0 to negative 1 to 0 to 1 to 0. So I'm starting out at 1, I'm going down to 0, going down to negative 1, coming back up to 0, going back to 1. So if we look at here, starting at 1, go to 0, go down to negative 1, go back up to 0 to 1. So when it comes to our period, what we need to look at is, where does it start repeating? Well, obviously with our unit circle and even with our graph, I'm at 1. Where am I at 1 again? Right here at 2 pi. So it starts repeating every 2 pi. Okay, but that's my domain and range. So now let's look at tangent and secant, because if we think, well, let's just go back here. So if I do tangent, here's interesting. This is tangent. Tangent is sine over cosine, or in other words, y over x. So my domain here goes, and actually I go to every pi over 2, okay, which is right here. Let's see if I can point that. No, not going to let me point there. But this is pi over 2. So this becomes a what we call a vertical asymptote. It doesn't reach pi over 2. Why is that? Well, if I'm doing sine over cosine, whenever my cosine is 0, so if I do sine over cosine, whenever my cosine is 0, then I have a undefined function, so it does not exist. So everywhere my cosine or my x is 0. So I come up here to pi over 2, well, it's undefined. I come down here to 3 pi over 2, my cosine is 0, it's also undefined. So then we look at our function here. When we're at 0, it's 0. And then we come to pi over 2, it becomes undefined right here. And it goes to really high number. And then it starts out at a really low number, comes back up to 0. And where is that? Every pi. Okay. So 2 pi, 3 pi, 4 pi, 0, negative pi. Okay. So at every pi, I'm at 0. Why is that? Because when I have 0 as a numerator and whatever as a denominator, then if I have 0 as a numerator, it's 0. So here at 0, my y is 0, so it makes it my x-axis, or crossing the x-axis there at 0. So 0, pi, 2 pi, so forth. Okay, so that's our tangent, and then our cotangent, okay, is similar, but it just goes the opposite. And here it starts at 0 and goes to pi. So then this is pi over 2, 3 pi over 2, 5 pi over 2 when I'm at 0. But where are my asymptotes? Now with cotangent, well, if we think of cotangent, cotangent is going to be cosine over sine, or in other words, x over y. So now anytime my y is 0, okay, then I will be undefined. So that will be then the points where I have a vertical asymptote. Now at pi over 2, my cotangent will be 0, and at 3 pi over 2, it'll be 0. So if we look back at our graph then, at 0 here I'm undefined. Here at negative pi over 2 or pi over 2, my my y value is 0. Okay, hopefully that explained that to give you a good quick gist of our domain and range. And then now if we look at secant and cosecant, so let's take a quick glance at those. So now secant is going to be the opposite of, so let me show you what happens. What is the reciprocal of secant? It is cosine. Okay, so if I plug in cosine x, you can see then it just bounces off where my peaks and valleys are of my cosine function. So the green is my cosine function. These are my secant function because it's a reciprocal. Reciprocal, you can think of it as bouncing off. However, why do I have a vertical asymptote here at pi over 2? Because secant is 1 over cosine. So here, wherever cosine is 0, pi over 2, 3 pi over 2, then it's going to be undefined again. So here goes up. I have undefined here at pi over 2, 3 pi over 2, so forth, every pi over 2 after that. Okay, so take away my cosine. That is what my secant looks like. And then we have cosecant. Okay, it's going to be the reciprocal of, you can guess it, sine x. So then it's going to be just the opposite. So if I put my secant in there, you're going to see they kind of overlap a little bit. Okay, what we need to know is our cosecant is going to reflect over our peaks and valleys of our sine, and then our secant will reflect over our peaks and valleys of our cosine. So here we have our vertical asymptotes everywhere that my y is 0. Okay, so here my y is 0, so at 0 and at pi, so forth, because cosecant is 1 over sine. Okay, so you can read through these. The domain of the tangent function is a set of all real numbers except every odd integer multiple of pi over 2. So in other words, pi over 2, 3 pi over 2, 5 pi over 2, so on. Same with our secant. Our secant will be pi over 2 and every odd. So we kind of need to know that. And then the domain of cotangent, okay, is going to be a set of all real numbers except every pi. And then our cosecant will also be except every multiples of pi. So reason being, if we look at that, okay, cosecant, okay, 0, pi, 2 pi, 3 pi, that's where. So my period for my secant and cosecant is going to be pi. Okay, in other words, it goes from 0 to pi. That's my period. Well, it goes from 0 to 2 pi where it starts repeating again, but we just need to understand where my undefined will be. Okay, let's move on. Our range, as I pointed out, our sine and our cosine will be from -1 to 1. Okay, I pointed that out on the unit circle and on the graph. My cosecant is going to be everything less than -1 and everything greater than 1. Same with our secant. Why is that? Here. Okay, everything greater than 1, everything less than -1. So that is our range, okay, our y values of our cosecant and secant. And then our cotangent and tangent then goes on forever up and down. So if we do tangent x, then you can see that it goes forever up, forever down. So it's all real numbers when it comes to my range. Okay, my domain is every pi over 2, okay, from there, but my range, I mean my domain, but my range will be all real numbers, negative infinity to positive infinity. Okay, and here's a table. I'm not sure if you ever want to memorize that, but you just need to understand when you're looking at the graphs, okay? You can use your Desmos graph to see that as well. Okay, let's look at next. Determine the period of my trig functions. Okay, my period is where does it start repeating? Well, as we saw with our sine and cosine, it's going to be every 2 pi. Okay, look at that graph, it's every 2 pi. When does my tangent start repeating? Well, if I'm looking at 0 going up, well, I'm here at 0. Where is it going up again at 0? Pi, and at 2 pi, and at 3 pi. So it starts repeating every pi. So that means my period is pi. Okay. My sine value is theta plus 2 pi k. And what that means is if there's a 1 there, it starts repeating at 2 pi. I can put a 2 there, it's at 4 pi, at 6 pi, so forth. So every 2 pi it starts repeating, where k is any integer. Let's look at our periodic function. That's just saying where does it start repeating. So my sine is every 2 pi, my cosine is every 2 pi. Well, my cosecant is just 1 over sine. So even though it reflects off the peaks and the valleys, my period is still 2 pi. My secant is 1 over cosine. My period is still 2 pi. However, my tangent is, of course, every pi, and then my cotangent is also every pi. So we just need to understand what our periods are in each of those. Okay, we are going to stop right there, and we will start another video on doing some actual problems.